Today we're gonna do part three, Operation Boost Core 3 Math. I'm gonna drop the link in the chat. Everybody grab your notebook, grab your calculator. Get ready to follow along. Private message me if you can't unmute for any reason. And just like always, y'all, try to get those cameras on. We love to see your faces. Make sure you guys are staying engaged. There we go, there we go. So pull up that document, Core 3. We're gonna be, discussing systems, more complex systems involving like quadratics and linears. Same deal, right? Dealing with that discriminant, dirt, exponent rules, exponential growth and decay, bunch of good stuff. Translating words into equations, order of operations, manipulating equations. So we got a lot of good stuff. So everybody,
Yeah, that's a great question. Logarithms only come up on the ACT. It's kind of like a special question. So if you ever want to talk about those, let us know, but they're not going to come up in the core series. There are some log questions in Sarah that I can assign you if you're ever interested in something like that. But we're not going to cover logarithms or matrices, even though they're both in the ACT. They're not on the SAT, and this is all geared towards the SAT. That being said, we're covering all of the math concepts that are on the SAT. So that means this is a whole bunch of stuff we're throwing at you at once. That means you're not supposed to retain all of it on the first go around. You need to be taking active notes, and you need to make sure that you're understanding the concepts that we go over while we're teaching them, so that when you review them, you can be like, oh, okay, that makes sense. Have you guys ever had a math lesson where you're like, oh my gosh, this is the first time I've ever understood math, and you're having a great day, and you get home to do the homework, and you're like, oh crap, I forgot everything that I just understood. That's where the note taking comes into play, and the annotated copies. So outside of that, we also have office hours. You can always shoot us an email so that we can, help you out with any of those specific concepts. So just make sure you're on the ball with that. That being said, when you're ready, let me get an R in the chat real quickly from all of y'all. If you got a notebook, pen, pencil, and you're ready to go, excellent. Perfect, perfect, perfect. We're going over some more tricky concepts. I'll tell you what to emphasize. I want you to be taking notes on anything that you think is important, but I'll show you what to emphasize or what I think is specifically important, and Kelvin will do the same while we're going through this. So without further ado, let's begin with core 3. So over here, we're going to review a concept that we found on core 2 real quickly. So whenever we have a system of equations, sometimes they're not always the same function, right? In this case, what two types of functions do we have? Feel free to unmute, because that's probably going to be easier than typing in the chat, low-key. Not going to lie.
Quadratic and linear.
Nice! Brianna coming in clutch today, killing it. Yes, quadratic and linear, perfect. So that means, let's remember this. If we have a line and we have a quadratic formula, there's only 3 types of solutions we can get. We can get 0 solutions, 1 solution, or 2 solutions, like this. Okay, so there's no infinitely many with a quadratic in a line. There's no way. It can only intersect 0 times, 1 time, or 2 times. That being said, whenever you're given a system of equations like this, the method that we typically prescribe is substitution. So over here, you see you have a y here, and you have a y here. So that means we're just going to substitute, right? So you got x equals x squared plus 3x plus 1. Now we're just going to bring everything over to the same side. 0 equals x squared plus 2x plus 1. And now, what's our final step here, y'all? Feel free to shout it out. It's probably going to be easier than typing it out. What's that?
Factoring.
Nice. Killing it, bro. Absolutely. So 0 equals x plus 1 squared. It's Sharish, right? Nice. Sharish, killing it today. Good stuff. Good stuff.
Oh, hey, real quick, Asher.
Yeah, what's up?
We started this. Thank you, Daniel. We actually started this last week. Remember, we did up to d equals rt.
Yo,
Daniel, thank you so much for reminding us.
Yeah.
But hey, real quick, let's do a quick recap of what we covered last week, just so we can touch on those points. So, quick recap, right? Anytime you have a system, right, involving a linear equation and quadratic, typically a solution in like a quadratic are where the graph intersects the x-axis, right? A solution in a system is where the graphs intersect each other, right? So what we're going to do is we're trying to figure out where are these graphs equal, right? So what we do is we set the graphs equal, and then to figure out how many solutions there are, we have to, again, set everything equal to 0, and then use the discriminant, right? So if you guys remember, the discriminant is b squared minus 4ac, right? So if b squared minus 4ac is positive, right? Remember, once you set everything equal to 0, a, b, and c are those coefficients. If b squared minus 4ac is positive, you have 2 solutions. Negative, you have no solutions. And if it's 0, you have 1 solution, right? We did that practice question down there. Just, again, anytime they have y equals, just substitute. And then when you substitute, you're going to solve for the other variable, right? So we substitute for y, solve for x, and then plug it back in to solve for y, right? Awesome.
Yeah, absolutely.
And now finally, d equals rt.
And so that brings us to the point, actually. So we've been telling you guys, okay, we're going to skip these in class so you guys can do them as homework, right? That means you guys should be doing them as homework. And if you get stuck, that's the perfect opportunity for you guys to email us or reach out during the next class and say, okay, this question was confusing, or shoot us an email, go to office hours, anything like that. That's really what's going to test your mastery. So make sure you're doing these. They're really good practice. So
hey, real quick, just to add to that, guys, give me an O in the chat if you know about office hours, right? Every single day of the week, you have someone literally waiting to answer any questions you have, okay? Rados.com/extra help. It's free prep, right? So if you have any questions, you guys should be doing like extra practice outside the session, time practice. Go to office hours and they'll answer any questions you have. So make sure you guys check it out, right? It's like 2 hours every day. I think there's like, that's like almost 20 hours of just like people just waiting to answer questions every week, right? So make sure you guys go check it out.
For sure. Really, really excellent resource. You can catch Calvin and I there sometimes on specific days. We'll be able to help you out, all that good stuff. Now, do y'all remember if we went through what each of the components of D equals RT? So if you remember, let me get an R. If you don't, let me get a D. We'll just go over it again, depending on what you guys say. Ooh, excellent. Perfect. Nice, nice, nice. Okay, so I'm just going to have Matthew Scott. What does D represent?
Distance.
Nice. What is R?
Rate.
Killing it. T.
Time.
Nice. That's what I'm talking about, bro. Absolutely killed that. Yes. So dirt is just distance equals rate times time. It's not always going to be a rate. It can always be anything. So if you like shuck oysters at a specific rate, I guess, then oysters is your rate, right? Or I'm sorry, I mixed that up. It's not always a distance is what I meant. You can do anything at a rate, right? You can shuck oysters at a rate. Instead of a distance, though, you'll be setting that equal to whatever your output is. So if you shuck like 8 oysters per hour, your output is oysters, not a specific distance. Distance is just arbitrary. It's there just as a placeholder, okay? So anyway, we have an actual example. We already went over this where she drives for 7 hours at a rate of 60 miles per hour, and we're asking how far she goes. Since it's D equals RT, we just plug in 60 and plug in 7 to get the distance, right? Then we have this complicated question that we went through. Kelvin, do you remember if we went through our exponent rules? We may have.
Guys, Y for yes and for no. Did we go over exponent rules? We did, right? Yeah, that's what I thought. Cool. Yeah, so just quick refresher, right? If you want to write mad spam, MADSPM, right, off the top, mad spam, right? You can just remember that, right? When you're multiplying with the same base, you add, right? MA means multiplying, add, right? When you're dividing with the same base, you subtract the exponents, right? And then when you have a power to power, P means power to power, right? Power to power means you multiply, okay? Just make sure you remember that, right? So x to the a times x to the b is going to be x to the a plus b, right? And we went over that example. X to a divided by x to the b is going to be x to the a minus b, right? X to the a times y to the b raised to the c, that's power to power, so you multiply the powers, right? It's going to be x to the ac times y to the bc. y to the x to the negative a, and you have a negative exponent, drop it down to the opposite side, right? So this would be 1 over x to the positive a, right? And then this next example, anytime you have a fraction as an exponent, just remember power over root, okay? Power over root. So it'd be x to the a, root b, right? And then finally, when you have the same base, you can set the exponents equal to each other, right? So a would equal b, right? And those are practice questions that we did. Hopefully you're here last week. If not, make sure you check the recap with the annotations, right? We also talked, yeah, so we also talked about, you can simplify fractions, right? So x to the 18 over 8, right? You could divide those by 2, which would be 9 over 4. When you're simplifying exponents, right, you can rewrite x to the 9. Remember, it's power over roots, right? This is going to be what? X to the 9 over 4, right? And then one way you can do it, you can ask yourself, how many whole numbers can I take? 9 over 4 is just the same thing as x to the 8 over 4, right? Times x to the 1 over 4, right? 8 over 4 is 2. And that would just be what? X squared. Fourth root of x is just going to be x squared, x to like fourth root of x, right? There you go. Perfect. Always, right? Anytime you're multiplying, right? Right now, yes or no in the chat. Can we use our exponent rules right now? Yes or no? Can we use our exponent rules? No, right? Because we do not have the same base. The only time the quotient rule and the product rule apply is if we have the same base, right? So your goal is to get the same base, try to get the lowest possible base. So 8 can be rewritten as 2 to the third, right? So it'd be, but still being raised to the second power, right? We just rewrote the number 8, right? That'd be 2 to the fifth times 2 to the third squared. Well, when you have a power to a power, we multiply, right? So that'd be what? 2 to the fifth times 2 to the sixth. And now that we have the same base, when we multiply, we add. So that'd be 2 to the 11th. We did this practice question, right? All we do with the negative exponent is we brought it down, right? So yeah, we did those two practice questions together. Just make sure you remember, flip the negative exponents. Number 12 was a really good one, right? We talked about first thing, try to just see how the original expression is in exponential form, right? So a is the same thing as what? Any number by itself, there's a 1, right? Oh, we didn't do 11 and 12. All right, Gabriel, did we do 11 and 12?
I know we didn't do 12, but we may not have done 11 as well. So let's go through that.
All right, dope, perfect. So let's actually have one of you guys walk us through this, right? So how about Matthew Scott? You want to read the question for me? Matthew Scott? Okay, yeah, I remember you have a dog. No worries, no worries. All right, let's have Nolan. Nolan, can you read number 11?
Sure. I'm actually just a little bit confused on how to do this. I was just
That's okay. Can you read the question first, and then we can walk through it together?
Expression x negative 2 y 1/2 over x to 1/3 times y to the negative first, where x is greater than 1 and y is greater than 1 as equivalent to which of the following? I mean, actually, I think I can do this.
You got this, right? All right,
Okay.
so first thing, right? The original expression is in like fractional form, right? And all the answers are in radical form, right? But let's first deal with what? The negatives, right? So what do you know? What can you do with how can you make those negative exponents positive?
You can put them on the denominator and numerator. So it'd be
Exactly, just flip it, right?
right. And so you would have y 1/2 x squared. No, I'm sorry. Y 1/2 y and then x.
Perfect, right? The
squared.
y moves up, becomes
Right.
positive. And then the x to the negative 2 moves down and becomes positive, right? So that'd be what? X squared
And
times
that's
x to the 1/3. Awesome, right? Second thing you notice is like looking at the answers, right? That you typically want to pull out, right, as much as you can from the radical, right? So we already have y and x squared pulled out. Do you see that, Nolan?
right.
Awesome, right? So now we just basically have to rewrite y to the 1/2 and x to the 1/3 in radical form, right? So we can just write y, anything to the 1/2 power is what?
Square root.
Amazing, right? So it'd be y times square root of y, and then over x squared. Anything to the 1/3 power is what? Remember, power over root, right?
Third root.
Yeah, third root, that's it, right? Third root of x. Because remember, x by itself is still being raised to the first power, right? So it's like 1
right.
over 3.
Okay.
Good stuff. So what's the final answer?
Let me just compare D.
Awesome. Great job. Really, really good job.
I
And that just goes to show, right? When you initially read that, it's like, man, like, I don't know if I know how to do this, but if you just break down what you know, typically you'll end up being able to solve it, right? So a lot of times, and here's another tip, anytime they give you like x is greater than 1, y is greater than 1, don't freak out, right? Typically, you don't even need that information, okay? Here, we're just rewriting, we're just literally changing how the original expression looks, right? What's the question, Jeevan?
Yeah, can't you solve it by subtracting the exponents too?
You could, right? But before you deal with, you even do your exponent rules, right? It'll be easier just to switch to flip, because look at all the answers, right? All the y's are on top, all the x's are on the bottom. So first deal with the negative, and then you could, then you wouldn't even have to use your just subtraction rule, right? Because you already flipped it. Does that make sense?
Yeah.
And typically, right, whenever, and we don't like negatives on the SAT, right? So if you can somehow get rid of like negatives, that's always like the best first step. But you're totally right, right? We could have done x to the -2 minus, but imagine that, right? We did -2 minus 1/3 times y to the 1/2 minus -1. We don't like negatives and we don't like fractions, right? So we gotta get rid of, if our steps involve those two things, we're typically going the wrong direction, okay? All right, dope.
And just to reiterate, whenever you have a negative, that just means switch the spot, right? So if we have -2, that means we're going to switch it to the denominator. If we have -1, that just means we're going to switch it to the numerator. And once we switch it, it becomes positive. So that's all that negative means, is that it's in the wrong spot, essentially, right? So this is -2. That's why there's x squared on the bottom. This -1, that's why there's y to the 1 on top, like that. Okay, so now this one's a little funky, okay? So which of the following is equivalent to 9 3/4? Real quickly, do this one yourselves, think about it, and give it like 10 seconds. Do any of the answer choices match what you're thinking, like your initial thought? So let me get a Y or an N. Do any of the answer choices match your initial thought? Okay, after this, Brianna Bass, after this, what would you feel like on this question?
What do you mean?
I mean, what would you be thinking? Like after you tried that, what's your first thought?
Well, obviously, my answer, my quote unquote answer, is not in the choices there. So
Yeah.
I kind of,
Right, you're kind of freaked out. It's like,
Yeah.
wait, that's correct. Why is this not there? So yes,
And real quick, just to emphasize that first step, right? Remember, it's going to be, anytime you have a fraction as an exponent, it's going to be power over root. So you can technically rewrite this as what, 9 to the 3rd, right? Root 4, but that's not an answer, right? So we probably have to see if there's another way to write this.
absolutely. So this is what we're all thinking, right? This is what we're like, okay, this is an easy question. Boom, it's just going to be this. Now, that's not one of our answer choices, right? So that means we got to be a little bit creative. So we see, okay, here are these base 9s, and they're not in the right form. So these probably aren't going to be correct. We can probably disregard these because they're not in the right form. But here are these other ones with a base of 3. So what can we do with our 9 then, you guys? Feel free to unmute. So we see that our answers have a base of 3. What can we do? Good. We can convert our base to 3. So we can go from 9 to 3. That is correct. Really good. And how are we going to do that? Feel free to unmute. Anyone?
Almost, Jason.
So
3 to what power is 9?
Yeah, so a really good way to tackle these questions, the first thing that you want to do is take your actual base and just plug in for that. So instead of 9 to the 3/4, we're going to substitute in 3 squared to the 3/4. And then, let's see, Sarah Thomas, at this point, what operation can we do?
You want to multiply the exponents, so you're gonna do,
Nice. What do we get?
you would get 6/4, which then kind of goes down to 3/2. 3/2. Yeah.
Nice. So if I have 3 to the 3/2, what's that the same thing as writing? How could I rewrite this yet again?
This is where I get kind of lost, I feel like.
Okay, so instead of 3 1/2, what if we tried to write this as a mixed number? What would that look like?
So that would be 1 and 1, 3. Wait, no, 3 and 1 and 1/2. Yeah.
Nice. So if I have 3 and 1/2, that's the same thing. I could rewrite this as 3 to the 1 times 3 to the what?
3 1/2.
Exactly, because that's equivalent. And so now if I just want to use my exponent rules, how could I rewrite this?
You could write it as 3 square root 3 or d. That's how.
Nice. Sarah just slayed that question. Excellent job. Perfect. Any questions? Okay.
Really good job, Sarah. And just to add to this, right? The cool thing about the SAT is you can work forward, right, using the original expression, or you can work backwards using the answer choices, right? So if you want to minimize this work, right, another way you could just look at this, right? So just as Asher said, A and B, right? 9 to the root, like third root of 9 is just what? 9 to what fraction, guys? Because remember, right next to that 9 is being raised to the first power, right? So it's power over root. So third root of 9 is 9 to what power? Let's drop it in the chat. Let's see if you guys got that down. And if you want to like write a little 1 right next to that 9 in the original answer, just so they see it. Okay, so remember guys, anytime it's in radical form, it's going to be power over root. Okay, so the third root of 9 is just 9 to what power? Let's see everybody drop it in the chat. Cool, right? 9 to the 1/3, right? 1/3 is not 3/4, so A is out of the picture, right? Now B is 9 to what? To what power? Awesome. 1/4, same deal, right? That's not equal to 3/4, out of the picture. C is the same thing as 3 to the 1/2, right? And then D is going to be 3 times 3 to the 1/2, right? Which if you use your exponent rules, that would be 3 to the 3/2, right? And now we just have to work with C or D. So once you convert 9 to 3/4 to 3, even if you get like 3 to the 3/2, right? You're going to automatically eliminate C because that's not 3 to the 1/2, right? So even if you didn't know how to convert D, you could still eliminate C and get D. Okay, really good job.
That's a dope way to look at it, bro. I never looked at it like that. That's a really great alternative solution using the answer choices. That's perfect. So always remember, Kelvin's reminding us, we can always use our answer choices if we're stuck. And this is a really great way to leverage them, just to rewrite them in this form as well. Awesome. So that being said, we're on to our next favorite funky function. These are kind of a little bit tricky, just conceptually. So we need to differentiate these from linear functions. This isn't in the packet, so I need you guys to write this down yourselves, okay? Linear versus exponential is a very big topic, all right? So I just want you guys to write that down. Linear versus exponential, somewhere in your notes. That's it. We'll talk about the differences in a second, but first let's define exponential. So in this diagram, we see we have an output. So remember, our y is our output. And in this case, t, our time, is kind of like our input. So we're going to input time, kind of like how x is our input in different functions, right? Next, r is our rate, but this is a different rate from d equals rt. And we'll talk about that in a second. That's the main difference between linear and exponential functions. And then p is our initial value. So what's funny about exponential growth and linear growth is that they both have an initial value, a rate, and an input. So y equals mx plus b and pr to the t are kind of similar conceptually. But our rate in exponential functions does not increase the same way that linear functions increase. And so we'll talk about that in a second. But anyway, these rates hinge on this concept of percent increase or decrease. And that's because every time we increase or decrease, we're doing that based on the previous value. So in a linear function, if you have like y equals 3x, you're adding 3 every single time, right? But in an exponential function, if you're increasing by 20% each time, okay, 20% of 1 is different than 20% of 1.2. So you're adding a different amount each time. If that kind of makes sense, let me get an S in the chat. Well, I'll go over it in different examples in a second. But that's the main difference here. That in exponential functions, you change a different amount each time. In linear functions, you change the same amount each time. So anyway, this is one of the most important concepts. It frustrated me so much as a kid trying to like calculate what my total was going to be before I got it. And then I'd be like, okay, what magic are they doing on the cash register? Because I would never get the same number. And here's why. Whenever we're doing percent increase, your rate equals 1 plus your percent. It's not just multiplying by the percent. It's insane, right? And your percent decrease is just r equals 1 minus your percent. So keep in mind we have 1 in both of these equations. That's typically how we mess up whenever we're calculating percent, you guys. So emphasize that. Really like put asterisks in your note or something like that. It's really big to emphasize that.
Yeah, and just to add to that, right? So you want to understand why do you have to start with 1, right? So like right next to just run x, right? So anytime, let's say something costs x dollars, it does not matter what you start with, right? No matter what x is, right? What number is in front of any variable by itself? A 1, right? So essentially we're saying we have 1x, or we have 100% of x, right? So we're increasing from 1, right? Or we're decreasing from 1, okay? So just remember that, right? You have the initial amount. Imagine like you put money in a bank account and it's supposed to grow by like 30%, and then you come back a year later and then you only have 30% of what you had, right? So if it grows by 30%, you have the initial 1 or the 100% and whatever it's growing by, right? And if it's decreasing, you have the initial, you're decreasing from that 1 or 100%, okay? Give me a 2 if that makes sense. All right, cool.
Okay, sweet. And so now let's model a 20% increase. We see this a lot in questions. So now let's just figure out what does that look like? That's just 1 plus 20%. Or in other words, we could write this as a decimal like 1.2. So like this is what we would multiply our variables by to make sure that we're increasing by 20%. Now, if I have 20% decrease, remember it's just 1 minus our percent. Sophia Hung, how are you doing today?
Good.
Excellent. So with a 20% increase or decrease, what's our rate going to be?
0.8.
Nice. Perfect. Yeah, that's it. And that's it. Yeah, it's either 1 plus percent or 1 minus percent. Really good stuff. Over here, let's see this example. Asher deposits $500 into an account that accrues 5% interest per year. How much money will be in the account in 10 years? So building off our original equation, remember, it's y equals p times r to the t, where p is initial, r is rate, t is time, and y is output. So Rachel Matthew, why don't you tell me how to input these numbers into this equation?
Okay, so would it be y equals 500 times 0.05 times, to raise to the power 10.
Super close. If I accrue 5%, what am I doing? Am I adding or subtracting money?
You're adding?
I'm adding money. So we're doing a percent increase. Do you remember what that formula is?
Yeah, 1 minus the 0.05.
Super close. When we're increasing, all we do is add instead of, so it's 1 plus our 5%. So what should this be in here?
1.05.
Nice. Perfect. Exactly. And then that's the exact correct equation here. So y equals 500 times 1.05 to the 10.
Perfect. And a few things just to add, right? If you can scroll up to the original note, scroll up a little bit, right there, yeah. So remember, you can never add decimals to percents, right? So if you could put in parentheses 1 plus percent, always convert that percent to decimal up right under a percent increase. Right? 1 plus percent, always write the percent as a decimal, okay? Convert to decimal, right? So 20% is 0.2, right? So it'd be like 1 plus 0.2, which is why we get 1.2, right? And then same deal with decrease, right? 20% decrease will be 1 minus 0.2, right? Which is how we get 0.8, right? So remember, always when you're dealing with percents, convert it to a decimal before you write it in the equation, okay? And then same deal here, right? With this example, when you're talking the same thing, like the example I gave, right? Imagine if your bank told you your account is going to grow by 5%, right? And then the next year, you only had 5% of the initial value, which means you lost 95%, right? So anytime you have percent growth or decay, all same stuff, right? Start with that 1 and then add or subtract, right? So 5% is 0.05, so it'd be 1 plus 0.05, right? One more time, what do percents hinge on? What number in the chat? Drop it in the chat. Anytime you have percent increase or decrease, or even percent growth and decay, always hinges on 1, right? So it's 1 plus or minus, right? You're going to add it if it's growth, you're going to subtract if it's decay, right? So let's see in the chat, right? If this said the account decays by 5%, what would the decimal be in the equation? Drop it in the chat. If it decays by 5%, it would be awesome. 1 minus 0.05, right? Which would be 0.95. Great stuff. Cool.
Sweet. And now, quick note, if the interest compounds more or less than once per year, so this is really important. If your frequency changes a different amount than your variable t, then make sure you change that, right? So if it's different than once per year or once per month or whatever your t is, then replace it with t divided by how long it takes to compound once. So let's think about that. If something compounds once every 2 years, let's see, going back to Logan, what am I going to multiply my t value by if it compounds once every 2 years?
You would multiply it by 2?
Close. It's once every 2 years. So in 1 year, do I get to compound?
No, it will be half.
Exactly. Perfect. So that's going to be t divided by 2. Perfect. Now, Logan, if it compounds twice a year, what's going to happen?
If it compounds twice a year, then that would be 2.
Nice. Perfect. That's going to be 2t because it happens twice. And then if it's once every 2 years, it's t divided by 2. So over here, I'm just going to let y'all take a second, look at this, figure out your own answer, and then I want you guys to private message me your answer in the chat. Okay, so now if you're kind of on the fence, remember we don't leave any questions blank on the SAT. So put your answer in the chat or direct message me the answer that you would choose now if you're still on the fence between a couple. So just choose one now. What are you going with? What's your gut say? What are you thinking? Okay, cool. Perfect. So we got a couple of contenders. Let's go through this really meticulously. Whenever you're reading this, we want to identify key terms like, okay, how frequently is this going on? Is this increase or decrease? Stuff like that. So let's go through it. In planning maintenance for the city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. So if it's every 20 years, does that mean 20 times per year? Or does it mean it takes 20 times to do it once, right? So that means if it's every 20 years, that means it's going to take 20 years to do something, right? So if it takes 20 years to do something, are we dividing or multiplying by 20? So put that in the chat. If it's every 20 years, are we dividing or multiplying by 20? In the general chat. If it takes every 20 years, that's dividing by 20, exactly. So that automatically knocks out A and C. We're dividing by 20. So it's T divided by 20. And since we're decreasing by 10%, remember, we need to keep in mind our percent decrease formula. So percent decrease is 1 minus our percent. And then we're going to convert that to a decimal. So that's the same thing as 1 minus 10%, or in other words, 1 minus 0.1. So that's going to give us 0.9. So the only one, this is 0.1 here, this is 0.9, has to be D because it's 1 minus our percent. And we decrease by that amount, so we're subtracting. If that makes sense, let me get an S in the chat. If you're still confused, let me get a C, and then we can talk through it, or you can wait after class and we can go through it again.
Awesome. And just to add a tip, remember, even when we were going through linear equations, we talked about the key words that point to rates, right? So each, every, per, those all mean like divided by, right? So just keep that in mind. Every 20 years just means over 20. Per 20, like if you eat 3 meals every day or 3 meals each day, those are all just fractions, okay? So keep an eye out for those keywords.
Perfect. Awesome. Okay. This one's also really, it's different. So let's talk about this real quickly, okay? Linear versus exponential. Here's a quick aside. I want you guys to take notes of this because like this isn't in the packet, but I'm showing you this, guys, anyway. So linear. Let's say we have something like y equals 2x. All right. With that, if we made a chart, if we made an XY chart, we'd have 0, 1, 2, 3. Over here, we'd have 0, 2, 4, 6. Right off the bat, we can tell this is linear because every time we increase the x by 1, our y increases by the same amount, 2. Okay? So it's increasing the same amount. That means it's linear. And so that means our graph is going to look something like just a straight old line, right? Now, if we have something exponential, so in this case, let's say we double something. So let's say we double every time. I'm going to show you why double is different than y equals 2x. So if we double every time, that's the same thing as saying y equals, let's say we start with 10. Okay, so start with 10, we double every time. So that means our initial is 10. Our rate, if we're doubling, is going to be what? Feel free to drop that in the chat. If we're doubling, what is our rate? What do you guys think it is?
Two.
Nice. Perfect. So if we're doubling, our rate is 2, and we're going to call this x. So now let's go through our value table. So let's say we have an x and a y. 0, 1, 2, 3. We'll do the same thing. So 2 to the 0 power is what, y'all? Just unmute for this one. What's 2 to the 0 power?
1.
1. Nice. So that's 1 times 10 is going to be 10 because no time has passed. So we still have our initial. After that, 2 to the 1 is 2. 2 times 10 is 20. And then 2 to the 2, that means we're just going to double this. So this is 40. Next time, it's going to be 60. So you see, every time we're increasing by a different amount. The first time we're increasing by 10. The second time we're increasing by 20. The next time we're increasing by, wait, did I do that wrong? Oh, shoot, that should be 80. Yeah, I did do that wrong. And then the next time we're increasing by 40. So you see how we're doubling each time. So we're going from 10 to 20 to 40 to 80. If it makes sense that we're increasing by a different amount each time, let me get a 1 in the chat. If you're still a little bit confused on what I'm trying to show you, let me get a 2. So that just means our graph is going to start a little bit slower, but then it's going to explode. And that's what exponentials look like. So in the long run, the exponentials are going to increase faster than a linear, regardless of whatever your rate is, as long as it's a positive rate. It's just going to increase faster than a linear function at a certain time. Sweet. Now that we got that out of the way, please be super careful with this next one. I'll read it with you guys, but I want you to come up with your own answers. Private message Kelvin. So a photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a job and copies at a constant rate. After 20 minutes, it has used 30% of the paper. Which of the following equations models the number of sheets of paper P remaining in the machine in minutes after the machine starts printing? So take a second, think about it, and then throw something in the chat. Or a private message to Calvin, my bad.
And take your time, guys. Look for the keywords, right? I mean, we discussed keywords for linear and exponential equations. Keep an eye out for those keywords. Ask yourself first, is this linear or exponential, right? Remember, linear means you're like adding the same amount every time, right? Exponential means you're multiplying by the same amount every time, right? Adding or subtracting, right? All right, 30 more seconds. Everybody send your answers in, A, B, C, or D. And then we'll walk through it. All right, so we got mostly D's, a couple B's, and A's. All right, so let's go ahead and walk through this, right? So it says that the photocopy machine is initially loaded with 5,000 sheets of paper, right? So we know that initially can either be like the starting value in a linear equation or the initial value in an exponential. That doesn't really help us, right? But we know that we're starting with 5,000, right? And now here's the key word, guys, all right? The machine starts a large job and copies at a constant rate, right? Constant rate means it's copying the same amount of paper, right, over a certain amount of time, right? So it says after 20 minutes, it used 30% of the paper, right? So guys, constant rate. That example that Asher showed us, right? if something's happening at a constant rate, that means you're adding the same amount or subtracting the same amount every time, right? If something's growing exponentially, right, it's not changing at a constant rate, right? We're changing at a different rate, as you guys can see, right? So L or E in the chat, is this exponential or linear? My bad, L, yeah, L or E. Awesome. Okay, this is a linear equation, okay? And here's another thing. If you're changing by the same amount, right? If you're changing, let's say like by the same number, right? It's linear. If you're changing by the same percent every time, it's exponential. That's another thing you want to keep in mind, okay? So here, right, this is just a rate, right? So it's copying what? 30% of the paper in 20 minutes. So what's 30% of? And then this is another like trick I want you guys to remember. Percent of means decimal multiply, right? So 30% of the paper just means what? 0.3 times what in the chat? 30% of the paper would be how much paper? 0.3 times the total amount of paper, which is
5,000.
awesome, right? So let's figure out how much paper was copied in 20 minutes. So it's a 0.3 times 5,000 is what in the chat? $1,500, right? So it does 1,500 pieces of paper in 20 minutes, right? So we can write that as a slope, right? How much paper, because remember, slope is usually going to be the amount of the change in y per unit x, right? So that's 1,500 over 20 minutes, right? So how much is that going to be per minute, guys? Awesome, 1,500 papers, right? Every 20 minutes, or divided by 20 minutes, right? Which means it's going to copy at 75, right, papers per minute, right? And think about logic, right? If you have 5,000 pieces of paper and it's copying, right? And you're trying to figure out an equation that models the remaining paper, right? Is the amount of paper in the copy machine going to increase or decrease? I or D in the chat, increase or decrease? Right, yeah, you're starting with 5,000 and you're decreasing at a constant rate of 75 pieces per minute, right? So what would the final answer be in the chat? There we go. Answer would be B, right? This is a tricky question, right? Because I know we just introduced exponential and then they throw a linear equation at you, right? But this just shows the importance of like being able to differentiate, right? So let's just go ahead and zoom into D, because a lot of you picked D, right? And let's see what the question would have told us, right? Guys, when you multiply by 0.7, that's what? What percent decay? What percent decay? Really good. 30% decay, right? 0.7 is a 30% decay, right? So if the question said, okay, the amount of paper is decreasing by 30% every 20 minutes, this is a 30% decay every 20 minutes. 30%, it's decreasing 30% every 20 minutes. Now let's go back, let's look at the wording of the question. Does it say the paper is decreasing by 30% every 20 minutes? Yes or no in the chat? No, right? It says that after 20 minutes, it used 30% of the paper, right? The key word, one more time, guys, is constant rate, okay? Linear, all right? Give me an S if this question makes sense now. All right, sweet. Any other points, Asher?
No, that's really good right there. Linear is always going to be constant rate, y'all. Whenever you hear constant rate, think linear immediately. Exponential functions are given away by percents. That is correct. So if you saw that 30% and that's what did it to you, that's why this is a tricky question, right? That's why we have linear here and exponential here. Whenever you see this in your answer choices, that means you need to be able to identify which one's going on. The term constant rate will tell you immediately what's going on. So look out for words like that. But if you hear words like double, half, or percent increase, decrease, decay, accrue, words like that, that means that you're going up. And that means you need to be thinking about an exponential because you're increasing by percent each time, not a fixed value. It's really good. If you guys have any additional questions, please stick around afterwards. Love to talk about this with you. Okay. Next, we have translations. I'm sure you guys know this. Sum means add, difference means subtract, product equals multiply, quotient equals divide. If you're good with this, let me get a G in the chat real quickly. I don't want to waste your time with stuff you already know. But if you don't know, I'm happy to go over it. Put a D in the chat if you want to go over it. If you don't know. Okay. Cool. Another word, whenever you see is just an equal sign. So if you say the word is, that means just put an equal sign. So what is, look, I can already use this, right? What is 15 less than half of 8? So that just means we're solving for that. What is 15 less than half of 8? So the first thing we're going to do is take half of 8, and then we're trying to find is 15 less minus 15. And that's it. So 4 minus 15 equals negative 11, stuff like that. That's all is going on.
And just to add to that, just to add to that list, as you can see, Asher just naturally put parentheses, of is multiply, half of 8 just means half times 8, Same thing when you see like, what is 12% of 5 means 0.12 times 5, of multiply.
Really great catch. Awesome. For sure. And then over here, whenever you hear difference of, whatever you hear first is the first thing you're going to put down. And then whatever you hear second is what you're subtracting by. And that's it. All right. Next, we have combining like terms. That just means either you have different variables or you have different powers that you're being raised to that you need to combine differently, right? So in this case, we have different powers, and that means we need to keep them separate. So these powers, this needs to stay with this. This is all alone. This is all alone. And then the constants need to come together. So 3x squared minus 6x squared gives us negative 3x squared. Negative 4x cubed is by itself. So we put that at the front always. And then we have this negative x showing up over here. Put that by itself. Plus 25. So we bring the constants together. So all that means is add or subtract or divide or multiply by terms that are either the same power or the same variable. That's it. That's all that is. So over here, we're doing the same thing pretty much. Disregard this fact right here. We don't need to know this. We don't care that I equals radical negative 1 unless we see something like I squared. But when that comes up, we'll talk about it. So anyway, let's take this out. We're looking for the sum of the complex numbers 2 plus 3i and 4 plus 8i. What's going to be the answer in the chat real quick, you guys? Nice. Perfect. Really good, you guys. Perfect. It's going to be C. Nice. Order of operations, PEMDAS. If you guys have heard PEMDAS a billion times and you already know what PEMDAS is, let me get a P in the chat real quickly. If you don't, let me get a D in the chat. We'll go over it. I don't want to skip any material you guys don't know. I only want to give you guys stuff you do know. Don't know. Perfect. Awesome. So we're going to skip that. Manipulating equations. This is actually pretty sick. We'll show you this real quickly. When we're performing operations on a single equation to find a value that is not x or y. So that means if we're not looking for x and we're not looking for y, if we're looking for a specific value like x minus y, 3x minus 2y, something like that, that means that's our first sign that we can probably manipulate the equation to give us what we want, right? So if we see 5x minus 5y equals 15, how do I get x minus y? Feel free to put it in the chat, shout out loud. What do we do?
Divide by 5.
Perfect. Excellent. Divide by 5. So we first factor out this 5 from 5x minus 5y. And then we get x minus y equals 3, just like that. And then that's all we're doing with the rest of these questions over there. Next, creating mixtures. Saline solutions, all that stuff. I hated chemistry. It sucked, but it's actually not as difficult as it seems. So real quickly, let's go through this example. My mom's an artist. She makes artwork all the time. I am not an artist, and I don't know my colors very well. So one time she mixed her blue paint with her yellow paint, and obviously it made green, but it blew my mind because I didn't know those two colors made green. So I put it in this example here. Whenever we have X gallons of blue paint and Y gallons of yellow paint, and we combine all of them together to make a perfect batch of green paint, how many gallons of green paint do we have? So we combine all of the blue with all the yellow. What's that give us?
X plus Y.
Good, really good. It's X plus Y because we're adding the paint buckets together. We're not multiplying, we're adding. So make sure you guys know that. Next up, my favorite cookie in the whole world, mass-produced, Oreos, obviously. And so now we have an Oreo question. So if I have 8 grams of cookie, I got 3 grams of filling. How many grams of Oreo do I have?
You get 11.
That's what I'm talking about. Absolutely. All you need to do is add them together, right? That's 11 grams. All we're doing is adding. That is the toughest part of saline solutions. I'm going to call on you guys in a second to remember what that means. So if I'm making a 25% salt solution from a mixture of X liters 20%, Y liters 40%. So if I'm doing X liters of 20% solution, that's the same thing as saying 0.2X plus 40% of Y is 0.4Y equals, and my desired amount is 25%. So it's going to be 0.25. But what am I multiplying this by, you guys? So if I'm combining these two together, what am I multiplying my 0.25 by? Same thing as the Oreos, same thing as the paint mixtures, y'all. We're just adding both of them together in the same little glass. So just drop in the chat, shout it out loud, combining them. What's it gonna be, y'all? What's going in my parentheses over here?
X plus Y?
X plus Y, exactly, perfect. X plus Y, because I'm adding X, I'm adding Y, and that's it. That's all it takes to do your saline solution. So really, all we broke it down as percent X plus percent Y equals desired percent times X plus Y. This is what every saline solution equation is going to look like forever and ever. This is all it's ever going to look like. It doesn't get tougher than this. But the 20% with the X, 40% with the Y, desired with the X plus Y. When you guys are done copying that down, let me get a thumbs up, because it's very important that this is in your personal notes over here. If you do understand, let me get a U. If you don't, let me get a D real quickly. Don't be shy about this, because this concept does come up, and I want you all to be prepared. Hey, what's good? Gabriel, you had a question or no? I see excuse, so I don't know if that means you can't unmute, which is cool if you can't. Nice, cool. All right, great. So it looks like you all copied this down. Perfect. Spent some time waiting for that. So now construct one yourselves. Just put A, B, C, or D in the chat whenever you're good to go. And we're zooming through this stuff, guys. We're almost done. Oh, private message me with your answer. Or actually, no, private message Kelvin. I'm going to take the next question.
So be really careful with how you're matching up the percents with the variables. All right. 10 more seconds. Go ahead and send me your answer. Awesome. Okay, so most of you got it right. So first deal, right? Anytime we're dealing with percents, are we gonna use percents in equations? Yes or no? Are we gonna use the actual percent in the equation? Yes or no?
No.
No. Okay, you always convert them to decimals, right? So automatically C and D out of the picture, right? And then we know that 60% by weight, right, of B, so 60% is, oh, my bad, A. Fertilizer A contains 60%, right? Fertilizer B contains 40%, right? So A is 60%, B is 40%. And then at the bottom says, where X is the number of pounds of fertilizer A, right? So right above A, let's put X, right? And then Y is the number of pounds of fertilizer B, right? So A is 60, which is X, so it has to be 0.6X. B would be 40% filler, and B is Y, so that'd be 0.4 times Y, right? And a total of 240 pounds. Sweet.
Okay, so if you guys have any questions on this, again, please private message either Calvin or me, and we will talk about it, okay? So with this one, this cumulative check-in, this is what I want you guys to really focus on. So think about this one more time, okay? Just gonna level with you. I'm taking you out of like whatever. If you haven't been paying attention, pay attention to this. Like, just like come back for a couple seconds, okay? Linear. We are increasing how? What type of increase or decrease are we doing? Constant. Constant increase or decrease. Constant increase or decrease. That means we're doing the same amount each time. So same add or same down every time. Exponential, not constant. Change, different every time. That being said, tackle number 7, you guys got this. Make us proud and private message me whenever you get your answer. All right, that's about as long as you guys should afford yourselves for deliberation on this question. At this point, just put what you're thinking, throw it in the chat, direct or private message me. Let me know what you got. Just throw it in the chat. So let's see. Cool. All right. So I almost got the alphabet. I got definitely some leanings, but I got A through D. I got everything, the whole spectrum on here. So it means let's take a second, dissect this, okay? The Downtown Business Association in a certain city plans to increase, nice, its membership by a total of N businesses per year. So let's actually input a number for this. In this scenario, let's say we're increasing by 4 businesses per year. If I'm increasing by 4 businesses per year, is that linear or exponential? So increasing by 4 businesses per year. Is that linear or exponential, y'all? Throw it in the chat. If you don't know, put in a question mark. That's okay. That's always acceptable. All right, what are we thinking, y'all? Let me get some more answers. Okay, linear, right? If we're increasing by a linear amount, that means we're in a linear equation, right? So that's going to take out what 2 answer choices? What 2 answer choices are we eliminating based off of that new revelation? We're increasing by 4 each year. Linear, good. We're eliminating C and D because those are exponential. All right, from here, we know if we're increasing, that's a positive slope. We've got that in all our answers. Where B businesses in the DBA at the beginning of this year, which function best models the total number of businesses the DBA plans to have as members X years from now. Since it plans to have them as members, that means we're adding our initial value because they were already there. So it's going to be A. We're adding B instead of subtracting B. Now, makes sense? Let me get an S. Still confused? Let me get a C. It's a really big question. It comes up a lot. This is a real stumper. Super important you guys understand this. Nice, 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 nice. Perfect. Cool, cool, cool. All right, sweet. Now that we got that, we got 15 minutes left. So that means we're just going to hop right into core 4. We might finish the core series in like 3 sessions, Calvin. That's insane.
Yeah, y'all are really doing a great job. I really appreciate in some past classes where students aren't super engaged and we're getting through material a lot slower. So we really appreciate your participation and y'all are doing great. You should be really proud of yourselves.
Yeah, you guys are on your A game today. I don't know what it is. You guys are slaying it. Super good stuff. Okay, our next core is going to be about, well, I mean, our first concept is composition or composite functions. I don't know why that was so hard to say. But our first concept over here, composite functions. So just remember, in f of x, it's the same thing as our y, right? That just means x is our input. That's it. So f of x can be used instead of y in most cases, f of x, where x is our input. That's it. So in this case, if I have f of x equals x squared minus 7x plus 9.
Real quick, Asher, let's give everyone a second to open the doc.
Oh, shoot. My bad. I didn't know you put that in the chat.
No, you're good. You're good. Everybody make sure you open the doc, save it to your computer, pull it up on your iPad if you have one, and be ready to follow along. Give you a sec and make sure it's the right document. Yeah. All right.
Okay, sweet.
Give me an R in the chat. I guess give me a 1 if you did not open it. And is anyone having issues with the document? All right, cool.
Okay, sweet. So if f of x equals x squared minus 7x plus 9, we remember x is our input. And we have f of 2 is going to equal what? What are we going to do here? How do we solve this? All we need to do is what?
Put 2 in for x.
Say that one more time.
Substitute 2 for x.
Excellent. Perfect. That's all that means. That means 2 is our input. So we're just plugging in 2 for x. So f of 2 equals 2 squared minus 7 times 2 plus 9. That's it. So now we can replace x with a variable. This is what's called a composite function. So if we replace x with a variable like this, instead of plugging in like a number for x, what are we plugging in this case? Feel free to just unmute. I think you guys got it. Say that.
You're plugging in the function.
Perfect. Excellent. Yes, we're plugging in the function this time. So f of g of x is the same thing as saying 2 times x squared plus 5x plus 8 plus 17. We're just plugging in this for whatever the x is over here. That's it. So we always want to work from in to out. So sometimes we have like, whoa, we have like 3 layers here, right? First, we're plugging in here to g of 1. Then we're plugging that into f. So if our first step is g of 1, what do we get for g of 1? G of 1 equals what? Chat,
2.
whatever you're thinking. 2? Nice. Really good. So that's just 2 times 1 squared equals 2. Now, since we know g of 1 equals 2, we're just going to plug that in for g of 1. So f of 2 equals 15 times 2, which gives us 30. And that's it. That's the key to composite functions, just plugging in. Now, on the SAT, this is what this will look like. Functions g and h are defined above. What is the value of h of 0? So what's the key to solving this?
Substitution.
Good. What are we substituting?
2x minus 1 for g of x.
Okay, I like that. But we're looking at h of 0, right?
Yeah.
So what does that mean we're doing with g of x?
When you're substituting the x, you're going to make it 0.
Yeah, right? So these are all x's, and it's h of 0. So that's the same thing as h of 0 equals 1 minus g of 0. So the first thing that we need to do is figure out whatever g of 0 is. And so g of 0 equals 0 minus 1 equals negative 1. Just plug that in. H of 0 equals 1 minus negative 1, which gives us 2. This is going to be D. So really good stuff. Perfect. Just plugging in, and that's it. After that, we have dividing polynomials. This is one of my favorite topics. I actually love polynomial long division. It's the same thing as regular division. So over here, I'm going to do this one for you guys, give you guys a little arithmetic break. If we're dividing 73 by 2, goes in 3 times, 6 minus 13. Uh-oh, it only goes in 6 times. That means we have a remainder of 1. Now, the way that we can write remainders, you put your remainder over whatever you're dividing by. So this is the same thing as saying 36 plus what, you guys? Feel free to just shout it out if it's hard to put in the chat.
0.5.
Say that one more time.
Half or 0.5.
Really good. Yeah. Plus 0.5 or 1/2, just like that. So 36 plus your remainder over what you're dividing by. If that makes sense, make it an S. If it doesn't, let me get a D. Same as usual. It's important that you understand this because it's easy for this, but it's not as intuitive when we get to polynomials. So I'm going to skip through all that because we got this. So if we're dividing x squared plus 5x plus 4 by x plus 3, the first thing we want to do is make sure this leading term matches this leading term. So if I want to turn x into x squared, what do I have to multiply it by, you guys?
X.
Nice. Really good. Perfect, perfect, perfect. So my first thing is x. Just like when you're regularly dividing, you're going to take this x and multiply it by x plus 3. We get x squared plus 3x. But remember, since this is division, we're going to subtract this from here. So we get minus x squared minus 3x. We do that, bring it down, 2x plus 4. How many times does x go into 2x? Twice. Good. So plus 2. Now we do 2 times x plus 3. And that gives us 2x plus 6. So we subtract 2x here, subtract 6 here, get negative 2. How many times does x go into negative 2? Is that possible? Is that a possible operation? Putting x into a constant? No, right? So that has to be our remainder. Instead of writing r negative 2, what can I say? I can say, okay, r negative 2, or x plus 2, what? So what do I put here, you guys? Using my remainder trick from earlier. You take the remainder, Perfect. -2 over x plus 3. Awesome. So minus 2 over x plus 3. So it's just plus your remainder over to whatever you're dividing by. But since this is -2, that's the same thing as subtracting 2 over x plus 3. That's it. Get a remainder of -2. Now, you know what? I'm going to call this our last concept. We might finish like 3 minutes early. That's okay. If you have any questions, stick around. But here we go. Remainder theorem. Finish up strong, you guys. So remainder theorem. All we're going to do, set denominator equal to 0. After we set our denominator equal to 0, plug in value into numerator. So whatever you get from step 1, plug it into the numerator.
And just to add, right, so remember, this is how you find the remainder, right? So the remainder is solved for by plugging in 0, right? Saying the denominator equal to 0, basically asking yourself, what is the 0 of the denominator, right? And then plugging that value into the numerator, right? So the first thing, right, x plus 3, right, equal to 0, what's x going to be? Or what value of x is going to make the denominator 0? Really good, right? X equals -3, right? So the remainder, when you divide these two equations, right, it's going to be what? R equals -3 squared plus 5 times -3 plus 4. So that'd be what? 9 minus 15 plus 4. Nine plus 4, 14 minus 15 is, my bad, 13. 13 minus 15 is -2. Awesome. So the remainder is -2. If we look back at that previous example, right, when we did the long division, that remainder that we got was -2, right? And this is a really good shortcut. So a lot of times we'll see questions that ask us to do the long division, but every single answer is going to have a different remainder. So all we have to do is do the remainder theorem to get the answer right away.
Okay, any questions, y'all, on this concept right here? Any questions? Feel free to unmute, private message, put a question mark in the chat if you have questions. No questions. Okay, cool. All right. Then if I have 2x cubed minus x squared plus 7, and I'm dividing that by x minus 1, what is my remainder? Private message me. And then once you all give me a remainder, we can pack up. I'll tell you your homework and we can just bounce. So what's our remainder, you guys? Cool, I got about 6 responses. If you don't know, feel free to put a question mark. That's all right. What is our remainder? I prefer a question mark to a guess, if you're wondering. Okay. So, okay, let's walk through this one more time. All we do, go to the denominator, x minus 1. Set it equal to 0. Get x equals 1. All right, that's it. So that's our first step. Step 1, set denominator equals 0, get a value for x. If you're good, let me get a g. Specifically, if you put a question mark or didn't know what you were doing, put a g, just so I know. Good, awesome, awesome, awesome. Step 2, plug that in. for x. That's it. That's it. Plug it in for x. So 2 to the 1 cubed minus 1 squared plus 7 is the same as 2 minus 1 plus 7. It's the same thing as 8. So really good job, you guys. Most of you guys put 8. Really good stuff. In the future, if you do have questions, please make sure that you ask them. I want to make sure everyone's on the same page and that you all are really prepped from this. I don't want to waste anybody's time. So that being said, really great work in today's session. Just make sure we're going to send you your homework in every recap email that we send. Make sure that you're completing that. We can check attendance. We can check participation, all that stuff on Sarah. And that's really what's going to help you guys do super well on the SAT. Like Kelvin said in the email, Sarah has proven to increase scores by up to 100 points across the board. Just the difference between National Merit Scholars and people who don't get National Merit Scholars was like a 10% difference on Sarah. It was a huge correlation. It was insane. So that being said, I'm invested in all of you guys right now. You guys are killers. I want you all to succeed. I'm not giving you this for busy work. I'm not telling you to do these things for busy work. I'm telling you these things to be successful. Everything that we go over is purposeful and it's designed to help you guys out. So make sure you review your notes and make sure you do your homework, and you're going to be in really great shape. If you are struggling with anything specific, please reach out to us. We can give you specific practice problems and we'll work through those with you. We'll make sure that you're really prepped and feeling good about everything that you're doing. Every single one of you has the potential to do whatever you want to do. If you want to get a perfect score on the SAT, that's totally within the realm of possibility, as long as you're willing to put in the time, energy, and motivation into getting there. And we will help you reach your goals, okay? Kelvin, is there anything else you wanted to say before we conclude?
Yeah, mark your calendars. First practice test is going to be this weekend. So make sure you guys mark your calendars for that. It's going to be what the scholars practice test is going to be same time, 12 to 4, right?
I believe so.
Let me see. Yeah, 12 to 4 on Saturday and Sunday, I believe. We'll definitely send you the information, but keep an eye out for that. And that's 12 to 4 p.m. Eastern Standard Time. Okay. And just as Asher said, make sure you guys are reviewing these documents. Remember, it's not just about coming to class, looking at the material at one time. You got to go back to it, review it. Like go back, review core 1, review core 2, review core 3 every week if you can, right? Just look over the question types that you struggle with, and reinforce the topics and the concepts by doing Sarah. Okay. The Sarah track is literally aligned with core. So for homework, right? Core, what, 1 through, what'd you assign, 3? 1 through 3?
Yeah,
or 1 through 4.
I've assigned 1 and 2 because we just finished up 3. So we're gonna assign 3 this week.
Perfect, yeah. So core 3 is due by next Monday. So again, all the instructions are in the email. Make sure you guys add the Sarah track and work through that. Also, the easiest section to bring your score up in are the math section and the writing and language section, okay? So if you guys can start working through like Sarah writing, right, boost writing. We already went through the writing packet. Actually, yeah, we did, right? Yeah. We went through the writing packet in week 1, right? So to reinforce those concepts, don't just review the packet, do time practice and look over the Sarah boost writing, right? Bunch of extra practice there. Keep it up. Go to office hours if you have any questions. Email us, right? You have our emails, and we're here for you. And thank you so much for coming. See you on Wednesday.
Have a great rest of your days, y'all. Peace.
Bye.